Good morning, one and all. Today we'll be continuing with the module 4, that is mixed design problem without superplasticizer. In our previous video, we have already seen the mixed design problem using superplasticizer. Superplasticizer is nothing but we'll be decreasing the cement content by using the superplasticizer for better strength, durability, and for the curing purpose, so that our work gets completed earlier. So those are using superplasticizer. This is without using superplasticizer. So the problem goes like this: design concrete mix proportion for 20 grade by IS 10262 2009. Grade designation is M20. Type of cement is OPC 43 grade. Maximum nominal size of aggregate is 20 mm. Minimum cement content is 320. Maximum water cement ratio is 0.55. Workability is 75 mm slump. Exposure condition is mild. Degree of supervision is good. Type of aggregate crushed angular aggregate. Maximum cement content 450. Chemical admixtures not used. Specific gravity of cement 3.15. Specific gravity of coarse aggregate 2.68. Specific gravity of fine aggregate is 2.65. So we'll go to the solution. Solution remains the same as we have done for the using superplasticizer. Only one point gets decreases here, that is without using superplasticizer we need to design the mix design problem. So first point goes as usual, target strength for mix proportioning. So target strength for mix proportioning is nothing but the normal compression strength what is there, it has to be greater than that target strength, means it has to be the maximum strength should be obtained. So this value or this formula you will be getting from IS 10262 2009 by using table number 1, that is standard deviation. FCK dash is equals to FCK plus 1.65 yes, where FCK dash is target mean strength for 28 days. FCK is characteristic strength, compressive strength for 28 days. S stand for standard deviation. This S value we will be getting depending upon the grade of concrete from table number 1. Now we have a grade of concrete as M20, so our standard deviation will be 4 because it is for M20 and M25 it is 4. So for target strength will be what, M20, so 20 plus 1.65 into 4, so our compressive, that is target strength is 26.60 Newton per mm square. Characteristic strength is 20, but our target we have to fix for mixed design is 26.60 Newton per mm square. So second point is selection of water cement ratio. Selection of water cement ratio. Maximum water cement ratio according to the IS 10262 for the mild condition, we have getting the maximum water cement ratio as 0.55. This 0.55 we will be getting it from the IS 456, that is RCC code book IS 456 2000 from table number 5. For mild condition you have the exposure condition here. For mild condition you have plain concrete and reinforced concrete. So for mild condition we have, for mild condition, that is reinforced concrete, minimum cement content, maximum free water cement ratio. So what is the for mild condition? Maximum free cement ratio is 0.55, cement content is 300, that is for M20 grade of concrete. So from this table we have got maximum water cement ratio has 0.55, but depending upon the experience water cement ratio is 0.5. Whatever the value we have got, it is greater than 0.5, so hence it is okay. So design remains safe for us. Next is selection of this is rather than 20 mm down aggregate if you have, then you have to adjust the values here, that is minimum cement content. So you will be going it in the next part. Selection of water content. Selection of water content is nothing but table 2 IS 10262 2009 for 20 mm down aggregate. For 20 mm down aggregate, you have got 186 liters, but this 186 liters is for 25 to 50 mm slump. If it is other than 50 mm slump, for every 25%, for every 25 mm you need to increase 3%. So in a given question, the slump value is 75 mm, but for 50 mm slump we have 186. So for 75 mm you need to increase 3%. That is, for every 25 mm you need to increase 3%. So 186 plus 3 divided by 100 into 186. So you will be getting the water content has 191.6 liters. So you can go to the table number 2. This is the table number 2 for nominal size, that is for 20 mm down aggregate you have 186 liters, but our slump value is 75 mm, so we will be increasing 3% to this 186. So after increasing we have got 191 liters of water. Next, calculation of cement content. We have already got water content, we have water cement ratio, we have to find only the cement. So cement will be on either side, it will go. So water divided by water cement ratio, you will be getting cement content. That is, water you have got 191.60 liters divided by the ratio, that is 0.5. Your cement content will be 383 kgs per meter cube. I've already told in my previous slide, IS 456-2000 table number 5, it will be giving you minimum cement content, maximum water cement ratio for M20 grade concrete, that is mild condition. Minimum cement content is 300. So we are getting 383 kgs per meter cube. So it is okay. Means we are getting more than the minimum value. Our minimum cement content should be 300. But we are getting 383. So whatever calculation we have done, it goes correct. This is the table. This is the minimum cement content for mild condition M20 grade concrete. You have minimum cement content as 300 kgs per meter cube. Next one is proportion of volume of coarse aggregate and fine aggregate. Table 2 IS 10262-2009 for zone 1 20 mm down aggregate water cement ratio. Depending upon this table, we are going to get the zone values. Our zone is first zone for 20 mm down aggregate, water cement ratio is 0.6, but we are taking water cement ratio as 0.5. So for 0.5 this value is correct. Means if water cement ratio is 0.5, then we have to use this table. If it is other than 0.5, then we have to increase for every 0.01, we have to decrease the water content. So we are getting for 20 mm down aggregate zone 1 water cement ratio for 0.5, we are getting it as volume of coarse aggregate. Volume of coarse aggregate will be 0.6. So volume of fine aggregate will be out of 100% or out of 1, 0.6 is coarse aggregate, so remaining will be 0.4. That is 1 minus 0.6 will be 0.4 will be fine aggregate. Next one, mixed calculations. Volume of concrete is 1 meter cube. Volume of cement is mass divided by specific gravity into 1 divided by 1000. So formula remains the same. Write down only the values. Mass of already cement you all have got, that is 383.16 divided by specific gravity is given in the question, that is 3.15 into 1 divided by 1000. To convert kgs per meter cube to meter cube, you have to divide 1 divided by 1000. So you are getting the volume of cement as 0.122 meter cube. Next we have volume of water. So mass of water divided by specific gravity into 1 divided by 1000. So mass of water we have got 191 liters, 0.60 divided by specific gravity of water is 1, or you can take it as 0.98. It will be not given in question, so it is assumed to be 1, that is specific gravity of water is itself 1 into 1 divided by 1000. So we are getting volume of water equal to 0.192. Now all in aggregate, volume of all, that is volume of cement, volume of concrete, you need to minus volume of cement and volume of water to get the volume of coarse aggregate and fine aggregate. So volume of all aggregate will be equal to, add the volume of cement and volume of water. In concrete you need to minus volume of cement and volume of water. So we will be getting the volume of coarse aggregate and fine aggregate is 0.686. So next one will be mass of coarse aggregate will be equal to, that is volume of all in aggregate into volume of coarse aggregate into 1000 into specific gravity. So volume in all in aggregate we have got 0.686 into volume of coarse aggregate will be 0.6 into 1000 into specific gravity is 2.68. So we are getting mass of coarse aggregate has 1103 kg. Mass of fine aggregate will be equal to D into volume of fine aggregate into 1000 into G. So volume of fine aggregate will be 0.686 into 0.4 into specific gravity into 1000. So we'll be getting the mass of fine aggregate has 727 kgs. So write down all the contents at one side, that is mixed proportion. For trial number 1 we have got cement equal to 383 kgs per meter cube, water content is 191.60 kgs per meter cube, coarse aggregate is 1117 kgs per meter cube, fine aggregate is 727 kgs per meter cube, water cement ratio is 0.5. So you have to write at the last what is the cement content, what is the water content, what is the coarse aggregate, fine aggregate and water cement ratio according to the mix design using IS 10262-2000 which you have solved now. At the last you need to write these values. Thank you.